polar coordinates, we're gonna review how to graph a polar point, and we'll talk about what a line looks like in polar coordinates, and we'll talk about something called the Lima scale in French. It's really neat, actually. Polar coordinates are really neat because you can graph some really neat stuff, flowers and all that fruity stuff that I don't really care about. Okay. Polar coordinates, you understand they are a circular grid system, correct? Okay, so if I plot a point in polar coordinates, it will be an angle and a radius. And the point is listed r theta, radius angle. Okay. And it's all radians. That's why we need to know our radians. All right, it's a real number because we're in calculus. So if I asked you to plot the point 2 pi over 2. Okay, where's pi over 2? And then 2 up, right? It'll be 1, 2. So there's your point. Pretty much is money. So, okay. How about this one? It's -2. Polars are, I think of polars as the opposite of how they're written. So I always do the angle first, and then what's a negative radius going to look like? -2. Okay. That's also the same as 2 negative pi over 2. Right, because you can go negative pi over 2, 2 units. So these are not necessarily negative axes. The negative comes in relation to what angle you're at. Okay, so that's a key thing to remember.
Yeah, I was trying to screw me up on that.
It's the proverbial rope across the trail that'll trip you and smack you in the face. Okay, so keep those couple things in mind. You can write a 1 point. I could probably write this 4 different ways just right off the bat. Right, because it can also be 2 and 3 pi over 2, right? So, I mean, there's another one. All right, so that's polars. I think we did polar coordinates battleship, right? So you guys were the first class I had that did that, so I think you're better off to.
Yeah, I really like that.
You should do it again.
If you want to convert to the rectangular grid like we're used to, okay, x is r cosine theta, and y is? Yeah, you got it. Very logical, right? And that's based totally on the unit circle and having those right triangles there. It all meshes beautifully. That's why we say math is very elegant. Yes, we do say that. And we believe it at the bottom of our hearts. I believe it wholeheartedly because it's just.
How would you call them proper fractions and imaginary numbers?
Hey, Smiley's so excited about it.
Okay, how do we convert this one here to rectangulars? So what's cosine pi over 2?
That's not even kind of right.
What's the x coordinate? 0, It's the same location. What's the y going to be? -2 probably, right? But sine pi over 2 is 1, so we get -2, and our point is 0, -2. And we can verify that on the graph. Same location, just a different grid system. Okay? What if I give you a point and ask you to convert rectangular to polar?
So x divided by r to the cosine of -1.
We don't have the angle. All we have is a rectangular coordinate. We have an x and a y. How did you calculate r based on it? X and y. That's that one thing that we've been studying for like 6 years now.
Yeah.
Pythagorean theorem. So what you end up with is r is the root of x squared plus y squared.
Oh, that's cool.
Yeah. Now see all these things, it's beautiful. They just come together so nicely.
Finally, this happens.
Isn't it nice though that you start to see some of this stuff now? Like everything was so compartmentalized in the past and now it's all coming together.
Yeah, Pythagorean theorem, I haven't seen that in like 3 years.
That's what I was thinking.
And I was great at that, so. Cool.
How do I calculate the angle?
I mean, I don't remember that.
May not have been called that.
This angle right here, how would I calculate that using right triangle trig? Yeah, tangent, inverse of opposite over adjacent. Okay. Do you want me to walk you through an example, or should we move on and give you homework time?
Move on.
You good?
It's, I do have a question
good?
about just the. So
Oh, do
for
tell.
coordinates,
Uh-huh.
does that mean that an infinite function or a continuous function is going to be, it's going to have a value of the integral, right? I mean, there's no infinity for coordinates, there?
Oh yeah, there is.
There is? So that, like,
It's circular, right?
yeah.
Most polar coordinate graphs start to repeat,
Okay.
right? Like you'll see the limit gone. All we have to plot is -pi to pi, and past that it just continues to do the same thing because it's cosine and sine basically, right? But there's a line. You know, let's talk about what a line looks like in polar coordinates. Through the origin. So we'll just do a line through the origin. If you're off the origin, it makes it a little bit more difficult, but okay.
That's probably.
Does it have a radius?
No.
No, a line in mathematics is never stops. A line segment or a ray doesn't either. A line segment does, but not a line. So is there any r?
No.
No, there's no radius, right? So can you think of a way to define where this line is?
The angle?
Yeah, just the angle. That's all it is. So if this is pi over 4, the equation of that line is?
So do all polar coordinates have to go through the origin?
No. You can graph a line not on the origin.
How does that work?
Oh,
It's not in the plan, man. It's in your book.
I don't want to know that badly.
It's r equals b secant theta minus alpha.
How about we just never speak of that again?
That's a good idea. Moving on.
Wait, no, use
Would
it, let's
that be on the
skip.
test though?
No, that's why I'm not showing it to you.
Okay.
We don't bother with it.
I was saying, man,
Okay,
text.
if- So let me give you a point. So what is the polar equation of a line through those 2 points? Obviously the origin, right? Faithfully. So 2, 3. It's right there. So we want to plot that line. What do I need to figure out? Yeah, no. Make me go rage on it. What do we need to figure out? The angle, right? So how am I going to figure out the angle? Yeah. It's just changing it to a polar theta. It's that same formula we use to change rectangular to polar. So that's a radian mode calculator. Punch it in. What do you get? Since I'm clairvoyant and all-knowing. No, thank God I'm not all-knowing. That would suck. It should be 0.98. Do you agree?
Yeah.
9.8279374.
What's the third decimal? Now I got my AP point. Hey, right.
Oh, what's the 4?
7.
Oh, so that should be a 3. You screwed up?
No, I can truncate.
You can do both.
I could chop it off.
That's what I do.
It's an estimate, so it should be rounded.
But it does say estimate anywhere in the question.
Oh, we put the estimate.
Thank you, Wyatt.
This intense debate real quick.
Moving
I'd
on.
like to see this.
Keep in mind that on the AP exam,
I'm looking
they try
forward
to
to
do
this
as
one more
much
time
in
taking
there
nap, guys,
graded as
so.
possible. On the AP
We
exam.
didn't finish the equation. All we did was try and figure it
What did that
But in
even
a
say?
No, wait, that's not what it's spelled like. I'm dumb.
I was like,
out. So polar equations are just y equals mx plus b.
No. No.
So why do we just find theta?
Oh wait, so because the line has no radius, so you can't find r. So r doesn't exist. All you need is the angle.
So we just found.
Okay, this shape, leave this
So
column.
mx plus b.
Yes, it's got an S in it, but there's no S in it,
that's just a
So it's got a C with a tail on it.
pretty much.
Oh.
I just can't write the tail very well because I haven't practiced. Anyways, this curve has this equation. Or, well, let's put an S in there. We're not eliminating S's from everything. Right? Okay. This is one of those ones that repeats. Okay. But part of the challenge in polars is determining where you need to start and finish. Okay, and that's one thing we're going to actually work every single day we're in polars for the next few days. So it repeats, but where? 0 to 2 pi? Negative pi to pi? Pi over 2 to 5 pi over 2? It's usually an interval of 2 pi. Sometimes it's not, though. Maybe it's 0 to pi. Maybe it's 0 to pi over 2.
Well, I mean, I think
Okay.
it would be the 0 to 2 pi because there's a 9 reflecting the angle. So
This one, you're thinking, and I like it. This one, the best way to graph it is to go from negative pi to pi. Okay, 0 to 2 pi, it starts to repeat after pi. Okay, but so that's why we would stop there and start here. So let's see. So let's set up a table and just plot some points and see where it goes. Right? Does it? That's an eraser. I do that.
Like 5.
I've been doing that for 3 years now since I got this board. Or 2 years, 3 years. 2 years. Okay, what's if I put negative pi in, what's cosine of negative pi?
Good question.
Negative 1.
Good job, Mr. Russell.
Is that right?
You led the negative one at the end.
-2.
Oh, yeah, I'm here, I'm good.
So you think and it breaks right around the corner.
Yeah, Joe's done a lot better than
So if I were to plot, let me get out a, nope, my content.
Go back to the picture.
Go to you and
I can go back to the screen, but you feel like Miss Doyle and put puppies.
Yeah.
I don't put puppies. I kick puppies.
So you. What is
I don't
the
think
sign?
you
I didn't just say that online.
I just said
I'm
that
good.
online.
Who's like?
I don't mean that.
Hoping everyone.
There goes my presidency. He kicks puppy dogs. Fantastic. And the enemy will totally take the rest of that out of context and not mention that I just recanted my statement.
They'll cut out that one part.
All right, where is this at?
It's 3 away from the origin.
Negative pi, negative 3.
Yeah.
Yeah,
Why is
not
that the
accepting
negative
math.
3?
Okay.
That's
The
weird.
opposite of
Yeah, it's the opposite. Here's negative pi.
Okay.
You have to go the opposite three spaces.
I thought that was pi though. Yeah.
It could be pi negative 3 as well.
Isn't that side 0 and this side pi? I mean,
But it's not.
Yeah.
So therefore negative pi is supposed to be on this
No,
side?
you, negative angles mean you go this direction, right?
Yeah.
Okay, so the negative on the polars is a direction indicator. It is here too, actually. Okay. Okay. Let's see. What's next? Negative 5 pi over 6.
I'm not getting anything out of that.
Okay, how about we do this? Let's start at 0. Is cosine 0 easier?
Hold on, guys, I'll show you something. Cheat sheets.
Okay, what's cosine 0?
Uno.
1. 2 minus 1 is, right? So at angle 0, we have 1 unit. Okay, what about pi over 6? Cosine pi over 6 is?
Negative, or square root of 3 over 2.
Okay, so we get root 3 minus 1, which is 0.7-ish. Okay, what about pi over 4?
Square root of 2.
Is this just a spiral? Or
Root 2 minus 1, 0.4. And how about pi over 3? Half. 1 minus 1 is 0.
This is a spiral.
And then we go to pi over 2.
Can you go back to the negatives because this is negative 1 0.
Right? Pi over 2, negative 1. Okay, what about 2 pi over 3?
1 negative 1/2.
So negative 2?
Use circle cut.
He's bound it when
If we keep going, we get what, 3 pi over 4, right? Which is negative root 2 over 2, so negative root 2 minus 1, negative 2.4. Okay. Okay, you see where this is going? And how we're gonna meet up with where we were gonna start. So here's your curve.
Oh, yeah?
Mm-hmm.
If we continued,
Apparently,
if we continued, we would see that our points follow the same pattern here, and the curve comes back around. It looks like that. So graphing polar coordinates with symmetry really helps. Okay, so we only graphed 0 to well, we went pi. We went from 0 to pi, right? That gave us half the curve. If we keep going, we would see that it repeats. So there you go.
So you tried to calculate the area of that, but not like the inner oval. Is that what we're getting to next?
Yeah. Yeah. So if you start at 0, your area is going to sweep this, right? And then it's going to come and calculate the entire area of this, which actually already encapsulates that, right? So if I were to calculate area of polars, if I wanted this entire curve, I would start at pi over 3, and I would end at pi, and I would multiply that by 2. Right? Because all you need is this big section
And then
times 2, and it gets you the other one. And you're done. Because that includes this as well, right? Right, so that would be how you would polar this one for area. Now we'll get to that next week. No, we won't.
Oh,
In 2 weeks.
Okay.
Okay?
Are we going to be rotating?
It's just a
around
primer.
this axis and stuff, or no?
No, we just do area. Like I said, the challenge in these is finding where to start and stop.
Weird shapes.
Like on this problem, just graphing it, where do you start and stop? You could do all of it. It's a lot more work, right? But if you can figure out just going 0 to pi works, that's a lot easier unit circle, and it gets you the rest of it symmetrically.
seems like it's a lot harder to predict how your function.
The functions that we are asked to work with are very straightforward. Like, well, you've got to get in polar mindset. They're the easiest polar coordinate graphs. You know, we'll be doing, you know, stuff like that. Okay. So, or something like that. Okay. So, I mean, it's not completely easy. You have to figure those out, but it's definitely the easier of the polars. What do you want?
Where's this? This is important.
Does it matter?
And actually, I'm kind of curious on how to use this.
You have a GPS.
Yeah.
It's a polar coordinate system, right? Latitude and longitude is based on angles. Yeah.
Is that it?
So it's compasses, map finding, navigation. It's all a variant of polar coordinates. On a 3-dimensional surface even, right? We're just studying 2-dimensionals. Okay. All right. Yes. To answer your question, Danielle. My goal is to not give you a break. Good response. You just earned brownie points.
and burning points count for nothing.
No, they taste pretty good.
They're
Only if you got a brownie at the end of it all.
They're imaginary, so I don't know what type of brownie points you're having.
They still do.
Okay, I'll take away the spiraling that was supposed to be on this homework, because that right there is posted on Google Classroom. Like I told you yesterday, the answers are with it, So check your answers, show your work, make sure you're doing your diligence, and if you have any questions on that, star it, mark it, and we can answer those when we come back, okay? So polar coordinate practice plus a BC multiple choice.
Is this chapter on classroom?
Yeah, but it has more work on it than that.
I mean the book.
Oh, that's a good question.